If I were to ask you how much this amount is, it would be very easy to answer, because all we would have to do is count how many units we must go up. 1, 2, 3, 4. Let's look at another bar. Another bar that is 1 wide. And you tell me how much we have here. Well, it's very easy, isn't it? All we have to do is count 1, 2, 3, 4, 5. We just have to count how long the bar is. Can you tell me how long this bar is? That's also easy, isn't it? All I have to do is count how long the bar is. 1, 2, 3, 4, 5, 6, 7. We're going to look at another bar now. Can you tell me how long that bar is? You might be able to guess, and everybody could make a guess. Someone might guess 6, someone 7, someone 8. We might get lots of guesses. And one of the guesses might even be right. But we really don't know how long that bar is unless we measured it. If we measured it, we might be able to find out how long it is. But the mathematician has never been noted for being exceptionally ambitious, only very clever. And the mathematician is always the first one to admit that I don't know how long it is. How much is this? How long is it? The mathematician will look at it and he'll say, I don't know. I don't know how long that is. I can't count it. Now the mathematician uses the word, I don't know, so much that he gives that word, I don't know, a special name. He calls it X. This is X, which means what? I don't know how much it is. I can't count it. Here we can see we have 1, 2, 3, 4. We can count it. 1, 2, 3, 4, 5. We can count it. This we cannot count. This is X. It's 1 wide, but how long is it? We cannot say. Okay. We are starting to learn names of things. We know what the name of this is. This is 1 little unit, which is 1 over and 1 up. We know what the name of this is. This is X. It's 1 over and I don't know up. So we just call it X. We've learned how to name lots of things. We've learned how to name our square here. The name of our square here is 2 squared. It's a square and each side is 2. Let's learn how to name something more. Let's look at our big square here. Can we name the square? In order to name the square, we must count the length of its side. But we don't have any divisions. We don't have any little lines showing us where a unit starts and where a unit ends like we do here, or like we do in our square right here. Here again, we could only guess. Looking at it, we must say that it is how long? Well, let's look. It is X long. It is the same length as our X. It's the same distance over as X. It's the same distance up as X. So now we can name it. It is X both ways, or X squared. At the beginning, we decided that we were going to learn how to factor x squared plus 3x plus 2. a problem that even a child can do. The problem, however, in doing the factoring was not the complexity of the mathematics, it was the language barrier. Now we are at a point where we no longer have a language barrier. X both ways means x squared. Here this means something now that we can see. We have x squared. Here we have 3 x's. We can count out 3 x's. 1, 2, 3. And we can count out 2 units. Good preparation before we actually start factoring is reading expressions and getting the amounts out. For example, if we had x squared plus 5x plus 6 written there instead, we would get out an x squared, we would get out 5 x's, and we would get 6 units. Preparation in reading the expression and getting the amount out is good practice before we actually start factoring. But now let's factor the amount x squared plus 3x plus 2. Does everyone know what factoring is? Factoring is building a rectangle. That's correct. Factoring is building a rectangle. We must take this amount right here and arrange it into a rectangle. We must build a box out of it. I'm going to show you how you can always get a rectangle out of an amount using x squares, x's, and units. You can always build a rectangle by placing one x on the side and the rest of the x's on the top. Notice we've allowed a little place in the corner where the units will fit. Did we factor the amount? Yes, we did. Because what is factoring? Factoring is building a rectangle, and that is what we did. Now we will record the factors. Remember, we have an over distance and an up distance. Our distance over is, from here to here is how much? From here to here is, I don't know, I can't count it. From here to here is, I don't know, is x. X plus one more is our distance over. X plus 1. Our distance up is what? X plus 1, 2. X plus 2. We have just learned how to factor an algebraic expression, and we just did it.